last data representation we're going to discuss is circle graphs. Really, one of the most common graphs there is, but yet the most difficult to understand. So stay with me. Stay with me. All right. Circle graph. Well, what's a circle graph, y'all?
Graph that's in the circle.
Graph that what?
Represents data in a circle.
Shows, I used a shorter word because of writing notes. Shows data, represents is a good word. But I'm gonna shows data in circle form. Parentheses. What do y'all like to call these kind of graphs? Pied. I hate calling it that. But, pie chart. But, I like calling it circle graphs, but then when I talk about it, I talk about pieces of pie, so why do I not like it? I don't know. I'm just dumb. So, pie chart. I hardly will ever call it a pie chart, even though I do compare it to pieces of a pie or pieces of a pizza. I always call it a circle graph, then talk about it that way. So, it is a pie chart. It's a graph that shows data in circle form. All right. Usually, it uses most of the time, a pie chart is used with percentages. But we must understand how fracts and maybe decimal, boy, that's terrible. Decimals, how fracts and maybe decimals also come into play. That's not very good. I touched it with my finger. I don't. Pie charts or circle graphs are a circle and you have pieces cut out of it. Not all the pieces are in equal form. Thus, we have different amounts for each piece. Okay. The circle graph shows, I was going to use the represents, but I like shows, shorter word. Shows one what? One whole. There you go. Circle graph shows one whole. Which leads us to how many percent?
100.
The whole circle graph is 100% total, correct? If it's a percentage circle graph, the graph, all the pieces of the graph have to add up to 100%. percent data, thus it's just number data. If it's not percent data, here's where it sometimes gets confusing and gets hard. If they don't give us percent data, they give us number data, we have to create a fract using parts to a what? Whole. Who said that? Good job, Parks. Where we have parts over the whole. I'll show you an example of that in a minute, but I want to tell you one right now. Let's say we survey 150 students. Okay? 150 students. And we ask them their favorite breakfast drink. And 75 of them say chocolate milk. I don't have percentage there in that information, do I? I have number data. 75 people said chocolate milk was their favorite breakfast drink. 75 out of how many did we survey? 150. So we make the fraction 75 over 150. That's what I'm talking about. 75 was parts. The whole survey was 150. Do you see how we have to be able to convert fractions if numbers are given to us? Because sometimes in circle graphs they don't give us percentage. Now some of y'all are smart enough already to know 75 is half of the surveyed people 150, and what is 1/2 as a percentage?
50%.
Right? What's half as a percent? If you get half the test right, what grade do you get? 50. 50%. So we converted, didn't we? And we could then draw the circle graph for those chocolate milk people would be half of the pie, right? 50% of the pie. So, do you see what I'm talking about? If we got percentage, the whole thing is supposed to be 100%. If we don't have percentage information, we must turn it into a fraction, parts over the whole. Now let's draw in our notes some charts so we can use these charts to draw circle graphs. These will be our examples to look back at. I wish that we could just draw the first one as a 100% chart, but when you do a survey, almost all the times, 100% won't be your only answer, right? It's broken into other things, right? Not everybody's going to like chocolate milk for breakfast. They're going to choose plain milk or orange juice or water or grapefruit juice or Sunny D or whatever. So never 100%, so I'm not going to put that one up there. But I'm going to draw this one. If this was a circle graph, and we had that right there, Duh. What do we have? This is a half. This is a half. And each piece is worth what?
50%.
This shows 50%, doesn't it? So if we have some data that is 50%, one part of the data has to be a circle with a line drawn across, the diameter drawn across through the center, so that half the circle is shown for 50%. Boy?
Boy.
Boy. All right. These represent 25% or 1/4. Got the idea? If you have data that has 25% as part of the data, part of your pie chart has to be one of those right angle things from the center, right? To be a 25% piece of the pie. It's got to look like that. All right, I'm going to keep going. What? What? That's what my goats do. Okay. These, I'm not going to write it in every one of them because it gets kind of cumbersome. But these are 1/6s, aren't they? Agree or disagree? 1/6. Well, if I have parts to the whole comes down to close to 1/6, then part of my pie chart has to be that size of a piece. Everybody with me on that? The only thing is I need a percent number too so that I can go with it. You remember dividing the bottom into the top to get a decimal? Yes?
Yes, sir.
And if I could get a decimal, I'll then move the decimal 2 places and get a percent, right? So 6 divides into what? What? 1? 10? 1? Aha, good. 1, 6, 6. Oh, I got it. Watch what I got on. Kill it and go back. Well, no, 14:30. Give me as much time as you can. What? Who? Porque no empieza a Wow, what's going to happen?
Repeat.
So, what is it? 16%, and I'm going to put a squiggly, meaning approximately 16%. So, if I have a percentage that says it's 15% or 17% or 16%, what size is my pie piece going to be? Right there, a 1/6 piece. Okay? All we're doing is making something so we can look back and have a quick idea. It's got to be close to that size. That's all we're doing right now in our notes. Or, we don't have to do this, and I'll make you do this every time we have something. Or would you rather have a cheat chart?
Cheat chart.
Cheat chart. Cheat chart. Cheat chart.